Let's look at an example. X is greater than negative 1 and x is less than 5. The key word here is and, which tells us that our answer has to satisfy both inequalities. First, let's look at each inequality individually. Here's all the numbers greater than negative 1. Remember, open point to show that negative 1 does not count as being greater than itself. And here is all the numbers less than 5. Since it's an and situation, we only need the values that fit both inequalities. In other words, we need the overlap, which is right here. We still use open circles as the endpoints because negative 1 is less than 5, but it isn't greater than negative 1. So it doesn't satisfy both inequalities. And that's the same with 5. It is greater than negative 1, but it's not less than 5. So both sides get an open point because they're not part of the answer. So now we know that any number between negative 1 and 5 could work. That doesn't just mean whole numbers either. 3.7 is within that range, as is 2.1, or negative 0.5. Finally, we can write and compound inequalities a little shorter. Since the answer is anything between negative 1 and 5, we can write x is between negative 1 and 5. Technically, it says negative 1 is less than x, which is less than 5, but it means the same thing. X is both greater than negative 1 and less than 5. When we write it like this, we have to be sure to put it in the order of lowest to highest, with the inequality symbols always being less than or equal to. It is actually possible for an and compound inequality to have no answer. For instance, this one, x is less than negative 2 and x is greater than or equal to 3. Here's the numbers that are less than negative 2, and here are the numbers greater than or equal to 3. We used a close point here because it's an or equal to, so 3 is included. Anyway, for and, we need the overlap, which is where exactly? There isn't any, because there is no such thing as a number that is below negative 2 and above 3. If a number is below negative 2, it can't be above 3. And if a number is above 3, it can't be below negative 2. So in this case, there's no solution. The other type of compound inequality is an or, such as x is less than negative 2 or x is greater than or equal to 3. This is the same as the previous example, just with or instead of and. You'll see that that one little change makes a huge difference. So first, let's mark our number line with all the numbers less than negative 2 and all the numbers greater than or equal to 3. Compound inequalities with or only require that a solution satisfies one inequality or the other, not both. So negative 5 would work because it satisfies the less than negative 2 requirement. Or 9 would work because it satisfies the greater than or equal to 3 requirement. Any part of the number line that is covered is a solution. So then what wouldn't be a solution? Well, the parts that aren't covered. Nothing between negative 2 and 3 is covered, so those numbers wouldn't be a solution here. Notice that this does include the number negative 2 because negative 2 is not included in that less than negative 2 inequality. So then what happens if the entire number line is covered? That's what will happen on this example. S is either less than or equal to 1 or greater than negative 1. The numbers less than or equal to 1 are here, and here are those that are greater than negative 1. Notice that every single number on the number line is covered by one inequality or the other. There's even some overlap, so some numbers are covered by both. Even negative 1, which isn't included in x is greater than negative 1, is included in x is less than or equal to 1. So it satisfies the compound inequality anyway. With or compound inequalities that cover everything, since there's no uncovered space, there are no numbers that don't work as a solution. So all real numbers, or all numbers on a number line, are the solution.